Okay, we're going to look at Chapter 8, Mid-Chapter Check, page 614. So if you could get to that page, you should already have all your answers filled in. I'm first going to show you the answer page so that you can check your work, and then I'll go over each individual problem in case you had any questions on any of them. And you'll be able to fast forward to whichever ones you need help on. You'll need to pause the video so that you can check all of your answers now. So for the first question, number 1, it's a vocabulary check. It asks us to define sequence, and I like to always say that sequence is a pattern. It says give an example of arithmetic and geometric sequence. So arithmetic would be where we're adding the same amount to the previous numbers, and then geometric is where we're multiplying. And so an example for the arithmetic is that we would be adding 3 plus, each number individual will be added to 3. So we've got 2, then 5, then 8, then 11. Whereas with a geometric pattern, we're talking about, so an example for geometric, sorry, I paused the video for a second and lost track of what I was saying. For geometric, we're going to be multiplying. So if we started out with something, let's say 2, and then our next one is 6, we're multiplying times 3. So our next one would be 18. And then we multiply times 3 again, and what is that? 3, 24, 54. And then keep multiplying times 3 each of the last numbers to create the next following digit. Number 2 says fill in the blank with the correct term, and it says a function is a relation that assigns exactly one output value and one input value. That is our function. That's the whole thing we're working on right now. So complete each function table, and it says it gives us an output, it gives us the input values for x, 0, 1, and 2, which are my favorite numbers to use. Then it gives us the function. Remember that function we can make with our little italicized f. And then we are finding our output values. So we're going to do 2 times 0 plus 6. And then 2 times 1 plus 6. And then 2 times 2 plus 6. And we're making sure that we have everything the same except that we're changing the input values for x. So 2 times 0 is 0, plus 6 is 6. 2 times 1 is 2, plus 6 is 8. 2 times 2 is 4, plus 6 is 10. And so we've completed the function table. And the next one, again, they're giving us 0, 1, 2, because they know that's my favorite. They've given us all the inputs, so we just need to plug them in. So I'm going to do 3 times 0 plus 1, 3 times 1 plus 1, and 3 times 2 plus 1. And sometimes what I'll do is I'll use 2 different colors and I'll just leave this like a blank so I can fill it in. Because sometimes for some reason we end up getting mistaken and maybe we'll do 1 times 0 and then 2 times 0 instead of 3 times 1 and 3 times 2. Like you just bring down the wrong numbers sometimes. So it's just important that we are keeping track of what we're doing and double checking ourselves so we don't make those silly mistakes. So for number 4, 3 times 0 is 0, plus 1 is 1. 3 times 1 is 3, plus 1 is 4. 3 times 2 is 6, plus 1 is 7. And there we go. Our outputs are 1, 4, and 7. Okay, for number 5, 6, and 7, it says to find the rule for each function table. So I'm going to go through this with you and this is literally the first time I'm looking at it as well, so I'm going to go through the steps that mentally I go through whenever I'm doing these types of problems. So for number 5, which is the easier of the 3, because I already saw that 6 and 7 are two-steppers, number 5, first we go from, you're judging from input to output. So to go from here to here, there's 2 things I'm doing. I'm either multiplying times 2 or I'm subtracting by 3. Those are my first things. So the first thing I'm going to do now, or the next thing I'm going to do now, is go to 4 and 8. And I'm going to try those out. Times 2, that's going to work. Minus 3 doesn't work. It's gone. Now once I get it to work once, I'm really hopeful it's going to work a second time, because if it works a second time, then I'm pretty golden. So again, I'm going to look at this one, 5 to 10. Does 5 times 2 equal 10? Yes, it does. So here I go. I'm going to say it's 2 times x. And remember, it's not x times 2. It's 2 times x, because the The number ahead of a variable is called a coefficient and represents a multiplication problem between a number and a variable. So please make sure that you're putting the number first and the variable second. So 2 times x, 2x. All right, so the next one that we're going to look at, this one's not going to be as easy, but I'm going to go through the same steps I just did because this is literally how I would do it. So I know to go from 1 to 3, I'm either going to do times 3 or I'm going to do plus 2. Those are my two things. If it's going to be easy one-steppers, those are the two steps that are going to be. So then I go to the next one. 2 to 7. 2 times 3 is 6. Doesn't work. So I'm already done. I don't have to try this one again because it didn't work. 2 to 7 is not 2 plus 2. That doesn't work either. Okay, I've already exhausted the ones that I thought would work. So I'm going to get rid of those. That's not going to work. It's not going to be an easy one-stepper. It's going to be a two-step. So now I just start experimenting. I'll say, okay, I'm going to do x times 1. I'm going to do x times 2 and make it 3. I'm going to have to do, if this is going to be 1, I'm going to have to do plus 1. Do you guys see that? That I'm working with this one first, because it's just easiest to start on the top. And if I had it as 2 times 1, I would have to add 1 to it to make 3. All right. Let's check this and see if it works with the next one. So I take my 2x plus 1, and I'm going to substitute in my 2. See if it works. 2 times 2 is 4. 4 plus 1 is 5. So my 2x plus 1, it's not going to work. So I need to get rid of that. It's not going to happen. So then I'm going to go to my next one. Now my next would normally be 3 times x, but I already know that 3x isn't going to work. Because if I do 3 times x and x is 1, I can't add or subtract anything here to make it work, so I'm already done. I'm already over it. So I'm going to skip 3 times 1 and I'm going to do 4 times x. Alright, so if I do 4 times 1, that's going to be 4. I want it to be 7 in the long run. Or sorry, I want it to be 3 in the long run. So I know I'm going to have to subtract 1 to make it work. So here's what I'm working with. 4x minus 1. If x is 1, it's going to be 4 times 1 is 4. 4 minus 1 is 3. That's the first one. So now I'm going to check this with the next two to see if it works. So 4 times 2 minus 1. 4 times 2 is 6. Or sorry, 4 times 2 is 8. 8 minus 1 is 7. Sure enough, that works with this one. So far, so good. So then I just have to check it with my very last one. And I'm going to do 4 times 3 minus 1. 4 times 3 is 12. Minus 1 is 11. Sure enough, that works. So my expression is 4x minus 1. And that's exactly how I do it. Just go through the motions. So my first thing is always like what I did with number 5 to start. I start that with number 6 and quickly see that that's not going to work, so I know it's a two-stepper. Then I just start with my multiplying to see if I can find something. There's going to be times where it's going to be division, and so I'm going to have to even go through another route. So we'll just keep trying it out. All right, so for number 7, let me get rid of all this. Oops, get rid of all this. For number 7, we go from 2 to 8. So I know to go from 2 to 8, I would either multiply times 4 or I would add 6. So I'm just going to test that out. 3 times 4 is 12. So that's not going to work. And then 3 plus 6 is 9. That's not going to work. So I already know neither one of those are going to work out for me. So I'm going to let that go now. So now I'm going to start my multiplication. In this case, I can start with 2, because here's the thing. If you start with 1, then you're not changing anything. You're just adding to it, and adding didn't work in the first place. So I'm going to always usually start with my 2. So I'm going to say 2x. So in this case, it would be 2 times 2 is 4, and then I would need to add 4 to make 8. Okay, so that's how I came up with my expression here. So now I'm just going to test this theory out on my next one. So 2 times 3 plus 4. All right, so 2 times 3 is 6, plus 4 is 10. It didn't work. All right, so 2x doesn't work. So now I'm going to go to 3x. So 3x would be 3 times 2, and I want this to equal 8, so I know I'm going to have to add 2. So that's what's going to start. I'm going to test this out on my next one to see if it works. 3 times 3 is 9. 9 plus 2 is 11. Ooh, that works. All right, try the next one. 3 times 4 plus 2 equals, let's see, 12 plus 2 is 14. Check mark, check mark. Sure enough, 3x plus 2 is my answer. So hopefully hearing my method, even though I know that took a lot of the video time, I hope that that helped you figure out how to do these. All right, for number 8, Arnold reads an average of 21 pages each day. Write an equation to represent the number of pages he read after any number of days. So first things first, I'm going to decide that D can represent the number of days. Okay, first things first, that's what I'm going to do. Now I know that if I do 21 times the number of days, that's going to equal the number of pages that I've read. Okay, which I guess maybe we'll let this represent P, number of pages read. So I've got 21 times D equals P, 21 times D equals whatever, okay? But 21 times D is the thing here. The fact that it says equation means I have to use an equal sign. So if you left out the equal sign, then you're not correct, okay? I don't care if you have it as 21 times D equals P or P equals 21 times D. Either way, you're giving me an equation with an equal sign. If you left out the equal sign and you just gave me 21 times D, I'm sorry, you gave me an expression, not an equation. So please make sure you give me an equal sign if it asks for equation. Number 9 says the table shows the cost of renting an inner tube to use at the Wavorama water park. Explain how to write an equation to represent the data in the table, and then give the equation for the data. All right. All right, so we want to write an equation to represent the data. And I see that it goes from 2 to 11, 2 or 3, and it says the cost of renting an inner tube. Oh, and it doesn't tell us which is which. Okay, all right. Sorry, I'm literally just reading this for the first time. So I've got, I'm going to go with my skills that I used in my other one. Let's see, this is either going to be times 5.5 or plus 9. All right, this one is not plus 9, and times 5.5, that actually does work. And then this one, does it work? 5.5 times 4, that would be 20, 22, 1 decimal point. Yep, all right. So the equation, equation I have, we're going to have, let's see, x, or 5.5 times x, or you can have $5.50 times x equals y, or y equals 5.5 or 5.50x. All right, so this is our equation for the data. And so it looks like every inner tube is $5.50, and this is the amount of people, and these are the amount of total cost. So I would say that x represents people or inner tubes, one of those two, inner tubes. And y represents total cost, which it already says. All right, so I know that kind of looks crazy, but this is what we're looking for, that it's y equals 5.5 times x. All right. Now that was the end. You know, I'm going to go ahead and go over one more example, so I guess those of you that are still tuned in are going to take advantage of this. But one of the things that you guys struggle with is when we give you an expression, or an equation, I'm sorry, and we ask you to graph it. So we say, okay, here it is. Here's number 1, the 2x minus 3 equals y, or usually it'll say y equals 2x minus 3, and it wants you to graph it. So we need to set up a table. The table is going to be, can I erase this? I don't think I can. I should have gone to another page. So the table is going to be x 2x minus 3, y, and then x comma y. And so I told you I always default to my 0, 1, and 2. And so I'm going to do 2 times 0 minus 3. Oh, I'm going to negatives. That is not on purpose. I'm going to make this, I'm going to make that addition now. I'm sorry. I'm changing up. I did not teach you guys negatives recently, so we're not going to do that. All right. 2 times 1 plus 3, 2 times 2 plus 3. And so 2 times 0 is 0, plus 3 is 3. So this is going to be 0, comma 3. This is 2 times 1 is 2, plus 3 is 5, 1, comma 5. The next one is 2 times 2, oh gosh, 4, plus 3 is 7, so 2, comma 7. So when I'm graphing this, I've already got some points to graph. All right, so I'm going to go over 0, up 3. Let me change the color. All right, up 3. That's my first one. Then over 1, up 5. And then over 2, up 7. And then say that I'm asking for an analysis, I could say that this is a linear equation. And I know that it's a little sketchy based on my amazing drawing that this is a straight line, but I'm not, proportional, so it's just the way it is. But I would say this is a linear equation, and this is how I would graph it. So I wanted to do an example of that as well. All right, I'll see y'all in school. Good luck.